Welcome back to our Arduino series for beginners. In this video, you'll learn how to use a digital sensor to measure temperature and humidity. I'll use the DHT11 sensor, which comes with the SoundFounder kit. This compact device provides accurate readings and is ideal for various different applications. The DHT11 is a digital temperature and humidity sensor that combines a capacitive humidity sensor and a thermistor to measure temperature and humidity in the surrounding air. It sends data as a digital signal, ensuring high reliability and stability. It can measure humidity from 20% to 90% and temperature from 0 to 60 degrees Celsius. The DHT11 is a versatile and popular sensor because of its simplicity and its low price. It's an excellent sensor for indoors environments. Let's connect the sensor. The DHT11 has 3 pins: VCC, ground, and data. Connect VCC to 5 volts on your Arduino, ground to any Arduino GNB pin, and the data pin to digital pin 2. Remember, correct pin alignment is critical. Unlike with the photoresistor that you learned about in the previous video in the series, if you flip the power and GND pins, you'll damage the sensor. Also, I reuse the LED from the previous videos in this experiment. As you can see, I'm controlling the LED with digital pin 11. Remember that there is a current limiting resistor in series with the LED to protect the LED from too much current. With our sensor connected, it's time to program our Arduino. We'll write a sketch that reads temperature and humidity values and displays them on the serial monitor. Additionally, an LED connected to pin 11 will light up with each new reading, indicating data acquisition. A library is a collection of pre-written code that provides a way to easily add functionality to Arduino projects without the need to write code from scratch. Libraries are essential collections of functions and procedures designed to perform specific tasks, such as controlling a specific type of sensor, managing communication protocols, or handling complex calculations. Libraries simplify the programming process by providing high-level functions and procedures that abstract away the complex underlying operations. By using libraries, you can save significant time since you don't need to write and debug complex code. Libraries often come with documentation and examples, making them a great resource for learning new concepts and techniques. In the program for this example, we'll also use an external library to help us use the sensor without understanding its operational details that lie underneath. The Arduino IDE version 2 makes finding, installing, and updating libraries easy because it includes a library manager. Many libraries can work with a DHT sensor. For this example, I've selected a DHT sensor library from Adafruit. You can find more information about this library in its GitHub repository. So let's go ahead to install the library before we can use it. First, within the Arduino IDE, access the library manager. In the library manager, use the search bar to look for the DHT library. You can type DHT into the search bar to find it more quickly. I'm using the one from Adafruit titled DHT Sensor Library. Once you've found the DHT library in the list, an install button will be next to it. Click on this button to start the installation process. The IDE will download and install the library for you. Now that your library is installed, you can include it in your project by adding the include statement at the beginning of your Arduino sketch. This allows you to use the functions and features provided by the DHT library to interact with DHT sensors. Now that we have installed the library, let's continue with the program. Let's look at the program line by line. This line includes the DHT library in the program, allowing us to use the functions and methods provided by the library to interact with the DHT sensor. Next, we define the DHT pin as a constant and assign the value 2, indicating that the data pin of the DHT sensor is connected to digital pin 2 on the Arduino. We also define DHT type as DHT11, specifying the type of DHT sensor we are using. This is important because the library can work with different models, such as the DHT22. Then we create an instance of the DHT class method named DHT or lowercase, initializing it with the pin number and sensor type defined earlier. This object will be used to interact with the sensor. The setup function runs once the program starts. As you already know, we use setup to initialize settings. We initialize serial communication at 9600 bits per second with serial.begin function, allowing the Arduino to send data to the computer so it can be displayed on the serial monitor. With a call to the DHT.begin function, we initialize the DHT sensor to prepare it for data reading. The loop function runs continuously after the setup is complete. It's where the main program logic resides. We use a relatively slow sensor, so we introduce a 2-second delay between each sensor reading. This delay also prevents flooding the serial monitor with data. We use the read humidity function of the DHT object to read the humidity value from the DHT sensor and store it in the humidity variable as a floating point number. We then use the read temperature function of the DHT object to read the temperature value from the DHT sensor and store it in the temperature variable as a floating point number. This code checks if the humidity or temperature readings are not a number, NaN, which indicates a reading failure. Notice the OR Boolean comparison operator in the if function. If not a number is detected, this line prints an error message to the serial monitor. The return function exits the current iteration of the loop function early if a reading fails. These lines print the humidity and temperature readings to the serial monitor, formatting the output for readability. This code turns on the LED connected to pin 11 to indicate that a new reading has been acquired. Here, we wait for 100 milliseconds with the LED on, ensuring it's visible to the human eye. This code turns off the LED, preparing it for the next data acquisition cycle. Go ahead and upload the program to your Arduino. Notice the LED blink with each reading, signaling that our sensor is actively measuring the environment. The serial monitor displays real-time temperature and humidity levels, showcasing the sensor's capabilities. In this video, you learned how to measure temperature and humidity using the DHT11 sensor. You also learned how to install libraries to take advantage of code written by other programmers and speed up your prototyping. So thank you for watching. Don't forget to like, subscribe, and hit the notification bell to stay updated with our latest tutorials. Happy making!